All right, ladies and gentlemen. So today, we are going to learn something called parity analysis. Parity analysis. Don't worry. I'm going to explain exactly what I mean by this, and I promise you'll understand, okay? It is not difficult. This is easy. So first, let's define what we mean by parity. Parity just means even or odd. Could be simpler, right? Parity just means even or odd. So if I ask you for the parity of 3, you would say that 3 is odd. If I ask you the parity of 4, you would say the parity of 4 is that it's even, right? Like I said, there's nothing more to read into that. Parity just means even or odd. Okay, here's something we need to keep in mind. We are only considering elements of the integer set. Okay, what this means is we're only considering integers in our problems today. And we'll go over what that means. So this little E symbol, this is how you draw this. That means is in, or is an element of. And this symbol, this weird looking in, here's how you draw it. This means integers, okay? Integers. Let's go over what integers are. Can someone shout out a number? 5 is an integer. Can someone shout out a negative number? -5. -5 is an integer. How about 0? Is 0 part of that? So remember, I'm not going to write this because we know this already, but integers are all of the kind of counting numbers, whole numbers, including all negative numbers and 0. Integers do not include fractions, decimals, percents. They do not. It doesn't include run-on numbers like 4.3 repeating. It doesn't include things like pi that never repeat, transcendental numbers and such. Okay, irrational numbers, rational numbers. It's literally just a -3, +2, 0. Okay. So we need to have one other piece here. 0 is an even number. Okay, and by number I mean integer. And you'll hear me just go back and forth between that usage here, and that's not rigorous, but that's what I mean. I mean number, I mean integer. Okay, so we got this out of the way. So what is the basic idea today? What are we trying to figure out? Here's the basic idea. Put an asterisk here, because this is kind of the important point. Here's the basic idea, ladies and gentlemen. I'm going to call it, the big idea. Here's the big idea. Integers can either be even or odd. This is the concept. Integers can be either even or odd. What we'd like to do is come up with a way, come up with a test to determine if a variable is even, odd, or a non-integer. So today we're not here to solve math problems. Today we're here to analyze math problems. That's why it's called analysis. So today you're not going to be solving any math problems, but you're going to be studying the nature of the letter. Okay, so let me just, so far we haven't done any examples, so this all just seems like a bunch of nonsense, okay, frankly. And it's getting boring, so let's get into it, okay? What can we do with all this? Okay, here, let's jump into an example. Consider this. Consider this example. Consider 2x equals 8. Consider 2x equals 8. What is x?
4.
4. So if you were to solve this little simple math problem, you would just divide both sides by 2, and x would be 4. Is 4 even or odd? 4 is even. We haven't even gotten the definition of an even number yet, but you know that. You know 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Those are all the even numbers. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, 23. Those are all the odd numbers, right? So you know 2x equals 8, divide both sides by 2, x equals 4. 4 is even, therefore x is even. So going into this math problem, you already know that whatever we do, we should come up with the, whatever we do, it should confirm that x is even, right? Y'all on the same page with me? Okay, so we are going to conduct something called an evenness parity test. Conduct an evenness parity test. So what we want to do is imagine for just a minute that we were not able to solve this math problem, okay? We wanted to do some pre-processing of this math problem to figure out if our answer is going to be even or odd. So I want to know, here's the big question I want to answer, okay? Is x even? That's my big question. Without solving, I want to know it. Without solving, I want to know that. Okay? And I'll tell you why we would want to do this in a second. Okay, so let's talk about even numbers. Somebody just give me someone just shout out an odd number.
3.
3. 3 times 2 is an even number. 3 times 2 is 6. Okay? Somebody shout out an even number.
4.
4 divided by 2 is 2. There's no remainder. So 4 is an even number. All right, so here, let's write this down. The definition of an even number is that it can be divided by 2 with no remainder. Let's make sure we understand, okay? If we start with the number 10 and we divide by 2, we get 5 remainder 0, okay? 5 with no remainder. Nobody writes it that way. They just write 5. So 10 divided by 2 is 5 with no remainder. So therefore, remember this symbol means therefore, 10 is even. Okay? So let me just show a counter example of this. How about 10 divided by 5? Well, let me put a different number, so because that's going to confuse everybody. Let me do 9 divided by 2. 9 divided by 2. How many times will 2 go into 9?
4 times.
2 will go into 9 4 times. And then what's the remainder? 1. Okay, so does 9 divided by 2 result in a quotient that has a remainder? Yes. Okay, therefore, 9 is not even. Notice I did not say that 9 was odd. We haven't proven that yet. You know that it's odd, and we'll prove it in a minute. But right now we know that 9 is not even, because it has a remainder when you divide by 2. Okay? So here's a big idea. Somebody shout out a number to me. Small number. 2. 2. 2 times 2 is 4. 4 is even. Somebody shout out an odd number to me that's small. 7 times 2 is 14. 14 is even. So I can perform this. If you throw any number at me, somebody threw 21 at me earlier today. 21 times 2 is 42. That's even. So you can give me any number, and I can spit back an even number to you every time just by multiplying whatever you send me by 2. Okay?
365.
Say it again.
365.
All right, so that would be 600, 730. Right? Is that right? 730 is an even number. So you just multiply whatever you send me and multiply it by 2. So the original 365 times 2, 730. 730 is an even number. So let's define, let's say even as 2k. 2 times k, where k is an integer. Okay, so that's what you were doing. You were throwing numbers at me. You were throwing integers at me, and I was multiplying it by 2. So what you were saying to me, 365, is that what you said? 365 was the k value. I stuck it in there and multiplied it by 2, and I gave you my even number. Okay, so here's what we want to do. Our evenness test is to substitute 2k for x and solve for k. I know that looks complicated. We'll do it in a second. If k equals an integer, any integer, then x is even. If k is not equal to an integer, then x is not even. Okay, so I didn't say x is odd, I just said it's not even. Because it could be a fraction, right? X could be we don't know what x is. All right, so this is all out of the way. Now we can just apply this test. Now we get to do something. We had to get all that out of the way so we could do something. Let's do it. So step one. Substitute 2k for x. Okay, so instead of writing 2x equals 8, I'm going to write 2 times 2k equals 8. Use the parentheses. So all I changed from consider 2x equals 8 to the next line is I just put in 2k where there was an x before. Now, multiply 2 times 2k. What you get? 4k. 4k equals 8. Now what do I do to get k by itself? Divide both sides by 4. These 4's cancel, and k equals 8 divided by 4? What's 8 divided by 4?
2.
Is there any remainder?
No.
So is 2 an even number?
Yes.
Okay, so here's what we care about. We don't really care. We don't care what k is or what number k is. Instead, we care that k is an integer. Okay, in other words, k is not a fraction. We didn't get a fraction. This test would fail if k was a fraction. So here's what we know. Because we passed this test, or I should say, since, that's what this means, okay? Since k is an integer, x must be even. That is pretty powerful. Okay, now very quickly, I forgot to write step 2. Step 2 was solve for k, okay? I'll write it in this next problem. So now we won't have as much to write this time because we're starting to understand what the process is. So the next problem is 2x equals 10. What is x? Is 5 even or odd?
Odd.
It's odd, right? So going into this, when we conduct our evenness test, it should fail, right? It should fail. Now, failing the evenness test is that it will result, k will be a fraction. That's how you fail this test. Okay, so here, let's do it real quick before y'all get bored. Step 1 is to substitute 2k for x. And step 2 is to solve for k. Okay? So here's what I'm going to do. I'm going to write 2, open parentheses, 2k, close parentheses, equals 10. Okay? So I substituted 2k for x. Now I'm going to solve. First, I'm going to distribute the 2. 2 times 2k is 4k equals 10. Divide both sides by 4. K equals 10 over 4, which is 5 over 2. Another way of saying this is 2 remainder 1. The big thing is there's a remainder, okay? It's not an integer. So because k is not an integer, x is not even. This is so important. I did not say x is odd, because remember, x could be, I know you know it's 5, but x could be a fraction. We haven't gotten to the point where we know that x is odd yet. So if we just performed an evenness test 2 times, I wonder if there's an oddness test. Okay? There is. So now we should perform an oddness test to determine if x is odd. 2x equals 10 is going to be our working example. We've already determined that x is not even. So we're still working with 2x equals 10. But now we need to talk about odd numbers. So first, somebody shout out a small number to me. 3. 3 times 2 is 6, plus 1 is 7. I've got a system. You shout a number to me, and I can shout back an odd number. So shout an even number to me. 2 times 2 is 4, plus 1 is 5. 5 is odd. Somebody shout another even number. Make it bigger, but not bigger than 20, because like 12. Okay, 12. 12 times 2 is 24, plus 1 is 25. 25 is odd. So you see what I'm doing? 6 times 2 is 12. 12 plus 1 is 13. I'm multiplying by 2, and then I'm adding 1. Okay, so here's our definition of odd. Much shorter than the definition of even. Here we go. Ready? Define odd. And I'm going to call it oddness as 2k plus 1, where k is an integer. Okay? So that's all we were doing just now. You were saying 6. I said 6 times 2, 12 plus 1 is 13. Guaranteed to give me an odd number. So let's perform the oddness test on this example. Okay, here is our example. 2x equals 10. Remember, we already performed the evenness test and it failed. Okay, so step 1. Substitute 2k plus 1 for x. Okay? So it's going to be 2, open parentheses, 2k plus 1, close parentheses, equals 10. So all I did was replace the x with 2k plus 1. That's standing in for any odd number, okay? So now we distribute. I should write what the next step is. So now step 2 is to solve for k, just like we did before. And here again, if k turns out to be a number, an integer, then it passes the oddness test. If it turns out to be a fraction, it fails the oddness test. So let's do it. Let's solve. So 2 times 2k, that's 4k. 2 times 1 is 2, so 4k plus 2 equals 10. Help me solve. Subtract 2 on both sides. 4k equals 8. Now what? Divide both sides by 4. K equals 8 divided by 4, which is 2 remainder 0. Okay, I'm not going to, of course, no one writes that. They just write that. You see there's no remainder? So this passes. This passes. Here's how you write it, okay? This means since, the upside down version of therefore. Since k was an element of the integers, x must be odd. Must be an odd integer. Indeed, as you already told me, 2x equals 10. You divide both sides by 2. If you were actually solving this, x would equal 5, and we know 5 is odd. Okay? We know 5 is odd. Guys, the question is, okay, so we learned how to do the evenness test, we learned how to do the oddness test. The question is, who cares? right? I mean, if that isn't a question on your mind right now, then you're not thinking. It's like, okay, that was really interesting, but who cares? Why would we care? Well, let me explain something. There are an infinite number of numbers. Let me say that again. There are an infinite number of numbers, right? There are an infinite number of even numbers, and there's an infinite number of odd numbers, right? Imagine you're a computer. Do you have infinite resources as a computer? You have limited memory, you have limited electricity. You know what I'm saying? The customer that owns you cannot pay an infinite amount of bills for you to run an infinite amount of time. So let me put it this way. This is hard to imagine, but I want you to think about this. Both even and odd numbers taken together form all the integers. That's an infinite set. It's infinite in all directions, okay? But we can say that even though the even numbers can also be infinite and the odd numbers can also be infinite, you can think of even numbers as half as big of an infinite amount. It sounds crazy, but half as big as the full-blown integers. You see what I'm saying? So yes, there's still an infinite number of them, but it's half the infinity of the whole number set, okay? Same thing with odd numbers. Odd numbers represent exactly half of the total numbers. So in the integer set, and the integer set is infinite, but what I'm saying is, if you can determine, now this is a simple problem, 2x equals 10 is a joke, but I've got problems that could be really complex. If you can get your computer to determine in advance that the answer is going to be even, or that the answer is going to be odd, and then it has to brute force check answers, because that's how computers solve. They don't know how to do algebra. They just check answers over and over again. If you can give it half as many things that it has to try, you have saved your customer half of their money. You get what I'm saying? So from a computer engineering perspective, this is just one example, it would be very useful to know whether this was an even number or an odd number. Or if it wasn't even or odd, like if it was a fraction, okay? Or at least not an integer. You see what I'm saying? So these tests aren't really interesting to us, but they are very interesting to computers and cryptography and engineering, okay? It is the elimination of half of your work off the table. So let's do a real example. Something you can sink your teeth into intellectually. Okay, here we go. Ready? Four x plus 3 equals 10. Do not solve this, okay? We're going to perform both of our tests on this. First, we're going to perform our evenness test. And then over here, we'll perform our oddness test. We're going to perform evenness first. If it passes evenness, we're done. We know that x must be an even integer, okay? If it fails and we perform our oddness test and it passes the oddness test, we're done. X is going to be an odd integer for sure. If it fails both of them, x is not an integer, okay? That's powerful. So let's do the evenness test first. Remember, evenness, I'll just write, evenness is where we substitute 2k. Oddness is where we substitute 2k plus 1. All right, let's do it. So evenness, 4, open parentheses, 2k, plus 3 equals 10. 4 times 2k, that's 8k, plus 3 equals 10. Just solving it out. Remember, I'm solving for k, so I'm going to subtract 3 on both sides, and now I've got 8k equals 7. You already know this is not going well, right? Because now we're going to divide both sides by 8. and I have a problem. Because k is a fraction. Remember, that means it fails the parity test. So k failed, okay? Or the evenness test failed. Fail. But all we know so far is that x is not an even integer. So let's perform our oddness test. Remember, that just means we're going to substitute 2k plus 1 for x. So let's do that. 4 open parentheses, 2k plus 1, close parentheses, plus 3 equals 10. Okay, this time we have to use the McRib property, the distributive McRib, McRib. 4 times 2k, 8k. Okay? That sounds like a good monitor resolution, 8k. 4 times 1, 4 plus 4. And now just bring down the plus 3 equals 10. All right, simplify this. So 4 plus 3, that's 7, right? So we've got 8k plus 7 equals 10. We're just solving for k. Subtract 7 on both sides. 8k equals 10 minus 7. What's that? Divide both sides by 8. I have a problem. K is a fraction again. Fail. I feel like this is a Mortal Kombat. Eliminate him. You lose. What does it mean that we failed both tests? What do we know? What have we proven? It's not an integer. So it doesn't, failing both tests is a good thing because now we know something. Here's what we know. This is a brilliant little idea. Let's put it in a brilliant little box, okay? Brilliant little idea. Here's what we know. Very valuable. X is not an integer. So I wrote x is not an element of the integer set, okay? So let's figure out what x is. I really don't care about this, but let's do it just to make sure that we, like if you said, okay, would you go to Vegas and bet on that? Yeah, I would. So let's solve for x. Subtract 3 from both sides. 4x equals 7. X equals 7/4. So that's 7 over 4. So it's not an integer because it's a fraction. Okay, so this confirms, right? So what we would do as a computer system is we would run these tests first to isolate the possible numbers we would try. And we know now that x is not an even number, it's not an odd number, it's not even an integer. And look at that, it turns out we were right. So this is why it's called analysis, because we were just analyzing the problem. So for young mathematicians like yourselves, you might be thinking, what is the point of this? But it's actually, we're trying to probe the nature of the problem as opposed to just the simple arithmetic of solving. Because at this point, you guys are so smart that solving that problem was silly. But determining the nature of the problem, that's more interesting. Okay, let's do another example, and then we'll be done with no homework. So just stay focused for me, okay? I just want you to do one more example. Here we go. We just have enough time to do this, okay? So I'm going to perform my evenness test. And that's where I'm going to substitute 2k. And then I'm going to perform my oddness test. And that's where I substitute 2k plus 1. Okay, we're not going to solve this. Okay? So let's perform that evenness test first. And I'm going to substitute 2k for x. So I'm going to write 2 open parentheses, 2k, close parentheses, plus 3, close parentheses, minus 4 equals 12. Okay, so now it's McRib time. Distrib. Get those distribution lines going. 2 times 2k is 4k. 2 times 3 is 6, so 4k plus 6 minus 4 equals 12. Let's do 6 minus 4. What is that? 2. So it's 4k plus 2 equals 12. How do I solve for k? I subtract 2 on both sides. 4k equals 10. I can already hear the sense of failure. Okay? Divide both sides by 4. That's 5 over 2. That is not an element of the integers. So this fails. So all we know right now is that x is not an even integer. So let's do our oddness test. Here we go. 2k plus 1. Everywhere there's an x. So that's 2 open parentheses, 2k plus 1, close parentheses, plus 3, close parentheses, minus 4 equals 12. We don't need these parentheses because it's just addition. Okay, now distribute. You could have even added 1 and 3, but it doesn't matter. So distribute 2 times 2k, that's 4k. 2 times 1 is plus 2. 2 times 3 is plus 6. Minus 4 equals 12. What is 2 plus 6? 8. What's 8 minus 4? 4. So this whole thing just becomes 4 plus 4. We got 4k plus 4 equals 12. Subtract 4 on both sides. 4k equals 12 minus 4 is 8. Okay. Divide both sides by 4. Yay! X equals 2. So here's the thing. 2 is an even number, but we don't care about that. We just care that k is an element of the integers. Therefore, we know x is an odd integer. Okay? That's what we proved. Were we right, ladies and gentlemen? Well, let's do it really quickly, okay? 2 open parentheses, x plus 3 minus 4 equals 12. Okay? So I'm just going to start by plussing out this 4. So I have 2 open parentheses, x plus 3 equals 16. I'm going to distribute the 2. I've got 2x plus 6 equals 16. I'm going to subtract the 6 on both sides. I have 2x equals 10. Divide both sides by 2. And voila, x equals 5. It was odd. And it was an odd integer. And we knew it in advance. So great job, guys. Thank you so much for your attention. And there is no homework. Have a great day.